When a massive tsunami struck Southeast Asia in December 2004, scientists noticed a strange fact. Among the thousands of victims, there were almost no wild animals. Elephants left the coast several hours before the wave hit. Deer and buffalo fled deeper into the island. The birds stopped singing and dogs refused to go outside. At the zoo in the city of Port in Sri Lanka, elephants suddenly started running toward the hills, breaking out of their enclosures. No one understood why. Only later did it become clear. The animals had sensed the disaster. Some experts believe that they detected seismic vibrations beyond the range of human hearing or sensed changes in the Earth's magnetic field. This became a serious reason for scientific study of animal behavior before disasters. And over time, more and more such cases have appeared around the world. What do all these behaviors have in common with the storm in Tennessee, recorded exactly 5 years later? In 2014, a group of ornithologists from the University of California discovered anomalous behavior in songbirds before a tornado. A flock equipped with GPS trackers suddenly changed its migration route, flying hundreds of miles away from their usual path. A day later, a devastating tornado swept through the area they had left. Amazingly, the birds left its path in advance. Scientists suggest that they perceive infrasound vibrations, low-frequency signals that precede the formation of a tornado. These signals travel through the atmosphere many hours before the actual storm. The human ear cannot detect such frequencies, but birds can. This gives them a head start and a chance to survive. Since then, such cases have been monitored more closely because birds can warn of disasters earlier than any weather forecasting systems. But even against this background, the discovery made by marine biologists from Miami is even more astonishing. Before Hurricane Harvey hit Texas in August 2017, scientists observed strange activity among marine fauna. Groups of sharks equipped with trackers began to dive deep long before the storm approached. Their behavior was recorded by satellites, and this was no coincidence. Experts explain this by the fact that fish can sense changes in barometric pressure. When the pressure drops, the water becomes less dense, and many species, especially sharks and tuna, dive deeper, where conditions are more stable. This behavior allows them to avoid injury and disorientation. This data is now being used in experimental marine forecasting models. The behavior of fish has become a kind of underwater harbinger of approaching bad weather. It serves as a reminder, even in the calmest waters, movement begins long before the storm. It is at such moments that tiny creatures on land start to behave just as strangely. At first glance, they are just ordinary insects. But ants have turned out to be more sensitive to changes in the weather than anyone could have imagined. In 2013, German scientists conducted a series of observations of ant colonies in natural conditions. They found that the insects change their activity depending on atmospheric pressure. When rain or a thunderstorm approaches, ants abruptly stop their outdoor activity, retreat deeper inside, and seal the entrances to their anthills. These actions occurred several hours before the clouds appeared. Moreover, when scientists simulated weather changes in the laboratory, the reaction was the same. This led to the assumption that ants may be living sensors, responding to changes in humidity, pressure, and even electric fields. One hypothesis is the presence of sensitive receptors that detect microscopic changes in the environment. But what if nature's loud response reaches us not only through behavior, but also through sounds? On summer evenings in the countryside, the loud croaking of frogs is not just background noise. Scientists in Brazil have noticed that the intensity of these amphibians' vocal behavior increases sharply before it rains. Moreover, certain species begin to sing exclusively a few hours before rainfall. Studies have confirmed that this is related to changes in humidity and air temperature. Frogs, thanks to their sensitive skin, are able to sense even the slightest fluctuations. But there are other aspects as well. Some species become more active before rain because it is the perfect time for breeding. Moisture helps the eggs survive. Thus, their instincts are closely linked to weather cycles. Field observations have shown that in 8 out of 10 cases, active croaking precedes rain. This discovery has found practical application. Local residents in South America use frog behavior as a natural barometer. But even more accurate signals come from animals we are used to thinking of as slow and unremarkable. Farmers have long claimed that if cows lie down on the grass, it means rain is coming soon. For a long time, this was considered nothing more than a folk belief. But British scientists from the University of Bristol decided to test this observation. For 3 years, they recorded the behavior of cattle in various weather conditions. It turned out that when atmospheric pressure drops and humidity rises, cows really do prefer to lie down. One hypothesis is that the animals are trying to keep a patch of dry grass under themselves. In addition, lower pressure affects the joints, causing discomfort. Cows lie down to reduce the strain. These observations were especially evident before warm showers and thunderstorms. The results of the study confirmed that cows can serve as living indicators of weather changes. Not technology, not satellites, but an animal standing in a meadow can predict rain more accurately than a forecast in an app. And while cows can sense moisture, creatures living underground display a completely different kind of premonition. In Nanning Province in southern China, employees of the local seismological center have long used an unusual method to monitor tectonic activity. They observe snakes. Cameras are installed on farms to record the behavior of the reptiles. In January 2007, cameras recorded a mass exodus of snakes from their shelters several days before an earthquake struck the region. These cold-blooded animals are extremely sensitive to underground vibrations and temperature shifts. Scientists believe that snakes can sense microseismic activity long before it is detected by instruments. Some individuals tried to leave their terrariums, ignoring the cold on the surface. This behavior became an important signal and allowed local services to be warned in time. Studies in Japan and Italy have also confirmed that snakes can serve as living sensors of tectonic activity. But sometimes, alarm begins in the tiniest organisms, those whose lives depend directly on air and wind. When clouds gather in the sky, biologists' attention is increasingly drawn to beehives. Bees and other insects display a remarkable sensitivity to approaching storms. Canadian scientists from the University of Saskatchewan conducted a series of observations of bees in the face of impending bad weather. They recorded that several hours before storm activity, the insects stopped collecting nectar and returned to the hive. At the same time, their activity dropped sharply by dozens of %. The reason is the change in the atmospheric electric field and the sharp decrease in ultraviolet light, which bees can sense. This helps them understand in advance that flying conditions are about to become dangerous. Beetles and moths behave in a similar way, and in some regions, insects have been observed to disappear from open areas a day before a hurricane. Such behavior has become a useful indicator for farmers who rely on pollinator activity in their work. However, there are cases when this premonition manifests not as flight, but as anxious nervousness. Many dog owners have noticed that before a thunderstorm or hurricane, their pets become restless, hide, howl, or scratch at doors. These observations have long attracted the attention of scientists. Veterinarians from Japan and the United States have collected data on the behavior of domestic animals before storms. Studies have shown that dogs really do react to drops in atmospheric pressure and changes in the electrical field in the air. They become anxious, their heart rate increases, and their anxiety levels rise. Breeds with acute hearing and a keen sense of smell turned out to be especially sensitive. Moreover, the animals' reactions began several hours before the first signs of the storm appeared. Some dogs tried to warn their owners by barking and displaying obsessive behavior. This data is used in veterinary practice to help animals during periods of unstable weather. Wind is one of the key factors affecting the behavior of bats. Scientists from Tel Aviv University conducted a large-scale study of colony behavior in Israel. They found that a day before strong winds or dust storms, bats completely cease their nocturnal activity. Usually active and mobile at night, they suddenly remain in their shelters, not leaving the caves. Sensors installed in nesting areas recorded a sharp decrease in flights several hours before the onset of weather anomalies. According to researchers, these animals have the ability to perceive changes in air pressure and acoustic waves that signal an increase in wind. They also studied behavior under conditions of sudden temperature changes. When it gets colder, bats switch to energy-saving mode in advance. These observations are used in planning ecosystem conservation and monitoring weather threats in hard-to-reach regions. But even high up in the sky, there are creatures that can sense things still undetectable by any instrument. Coastal birds such as pelicans, frigate birds, and albatrosses are among the most sensitive indicators of weather changes over the oceans. Ornithological studies on the Galapagos Islands have shown that pelicans begin to sharply change their flight altitude and direction a day before the approach of tropical storms. In 2012, during observations in the Pacific Ocean, it was recorded that pelicans left their usual nesting areas 36 hours before the onset of a storm, which later developed into a cyclone. Scientists suggest that these birds perceive infrasound and changes in air density, as well as the direction of air currents, which allows them to predict worsening weather conditions. Such behavior has become an important factor for ecologists and navigators who track migrations and weather risks. Especially in regions where technology cannot respond quickly, pelicans have become living weather stations. At first glance, a domestic bird seems far removed from natural intuition, but observations of chickens' behavior before earthquakes have puzzled scientists. In 2008 and 2016, farmers in France and India reported strange activity among their birds just minutes before underground tremors. The chickens began to run around chaotically, made alarm noises, and some even stopped laying eggs a day before the event. Scientists decided to study the phenomenon and found that birds are highly sensitive to low-frequency vibrations. These microseismic signals travel through the Earth long before the main shock, and chickens react to them earlier than any seismographs. Experiments measuring pulse and behavior showed that even slight ground tremors cause stress in birds. Some research stations in Japan now include domestic animals in the list of natural indicators. More and more often, chickens are proving to be an unexpectedly useful signal of impending danger. This is exactly what inspired international teams to create something truly large-scale and precise. The Icarus project, launched with the support of the European Space Agency and the Max Planck Institute, uses satellites to track animal behavior around the world. The idea is simple. If living creatures react to changes in nature, then their movements can be used as an early warning. Miniature sensors are attached to wild animals, transmitting information about their location, activity, body temperature, and the external environment. The system analyzes the data in real time. In 2019, the movement of a bat colony in South America helped detect a sharp change in climatic conditions several hours before a storm. In East Africa, changes in elephant migration routes coincided with seismic activity. These observations began to be integrated into the early warning system. In this way, animals become not just witnesses to natural changes, but part of a global monitoring network, precise, fast, and independent of human limitations. And this leads us to an unexpected, yet increasingly obvious conclusion that science can no longer ignore. By observing animal behavior in various corners of the planet, scientists are increasingly coming to the conclusion that nature creates sensors more accurate than even the most advanced instruments, from ants to elephants, from bees to snakes. Every creature perceives its own signals: microvibrations, electromagnetic fields, pressure, sound, light. These signals are invisible to us, but for animals, they are part of their familiar world. They don't make predictions, they simply sense, and that is their strength. Modern science has only just begun to grasp the scale of these phenomena. More and more laboratories around the world are integrating animal behavioral data into climate and seismological models. This is not a replacement for weather stations. Perhaps in the future, we will learn to listen not only to instruments, but also to nature. After all, while we are building technology, nature has already been living in harmony with change for millions of years.